Homework 3.2, Polynomial Functions, Video 2. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. Before we continue with this video, I need to correct something that I said incorrectly in the last video. In a haste to sketch these graphs, one of them was graphed incorrectly. It was the last one. The function j of x equals negative x to the fourth plus 6x to the third minus 9x squared. I had incorrectly drawn the graph like this. The end behavior is correct, so the discussion we had previously still stands, but this graph shouldn't have been located down here, it should have been further to the right. In other words, the graph should have looked something like this instead of like that. So same shape, but shifted over some. Again, I could use technology to get the graphs, but I'm trying to practice in my head the things I'm teaching you how to do, and mistakes are made. So in case anybody is watching the previous video and checked the four graphs and realized that the last one wasn't quite right, my apologies for that. And kudos to you for following through and verifying that the graphs were correct. I'm pretty sure the other ones were correct as well. By the way, I still have them written on the side over here so that I'm consistent with the functions that I use throughout these videos. All right, in this video, and my apologies, this is not video 2. This is video 3. Forgot to change that. But in this video, we're going to continue our discussion about end behavior because I need to inform you that not all polynomial functions are written in general form. In other words, not all polynomial functions are written with all their terms back to back to back with pluses or minuses in between. Some polynomial functions, such as these three, might already be factored. And in some cases, being factored is good, but not when it comes to end behavior. To determine the end behavior of a polynomial function, we need to ask a question about the degree and about the leading coefficient, which both are located in the leading term, the term with the highest power. Because these are factored, I don't know what the leading term is. In order to find the leading term, I could write out all the parentheses and multiply them, but as we're about to see, that won't actually be necessary. So, how do you find the end behavior for a polynomial function's graph when that function is factored and not telling you what its leading term is? The answer is multiply it out, but not really. We could write all the parentheses and multiply until there were none left, but I don't need to know every term. I only need to know the leading term. So how does one get the leading term and the leading term only when a polynomial is factored? The answer is pretend you start multiplying. So negative 2x plus 3. And since this is a square, I'm going to write the x minus 1 twice. There would be a whole heap of foiling and distributing that would go on to multiply this out completely. But to track the leading term, I just have to find the term that would give us the highest power. And the way to get the term with the highest power is to grab the highest power in each factor. In other words, to find the leading term of the entire polynomial, you simply multiply the leading term in each factor. For example, this last factor's leading term is x, so is this one, and this one. And this negative 2 is a factor. By definition, a factor is part of a multiplication problem, and this negative 2 is a factor. So, and it's its own leading term, it's the only term in this factor. So if you wanted to locate the leading term of a factored polynomial function, you simply have to multiply the leading terms of its factors. Since this had 4 factors, I would multiply these 4 terms. Negative 2 times x times x times x, that is negative 2x to the third. Now, what comes after that? Don't know, and frankly, don't care if all I'm looking for is the leading term. And now that we have the leading term of negative 2x cubed, we can analyze it properly. Remember, the two questions you ask the leading term is the degree odd or even? The degree here is odd. And what that means is that we have opposite ends. Now you can think this, you don't have to write this, I'm doing it for instructional purposes. And the leading coefficient is negative. That means that the right falls. just think of the first sign as pointing the direction of the right end of the graph. Negative, right points down, positive, right points up. Now, this isn't the end behavior in total, this is just describing how to find it. So now that I know these two things, I can say what the end behavior is. If the right falls and the ends are opposite, what does the left do? Well, if it's opposite, then the left rises. And we already said that the right falls. So it's actually not difficult to find the end behavior of a factored polynomial function. You simply have to multiply the leading terms of its factors to create the true leading term for the entire polynomial function and then analyze it accordingly. I invite you to pause the video and see for parts B and C if you can locate the leading term and as a consequence determine the end behavior. Now either you paused or you didn't, but either way, I'm about to bust them open. All right, so let's take a look at Q of X. Again, to find the leading term, you simply have to multiply the leading term in each factor. And if you have a squared factor, you might want to write it twice, or whatever the power it is. It's not actually necessary, I'll show you why in just a second. But if I wrote out the x plus 1 twice, then to unearth the leading term for the whole function, I just have to multiply the leading term in each factor. That factor's leading term is 5, this one is x squared, this one is x, and this one is x. So if I multiply all those together, I get a 5, x to the second, I pick up a third x, I pick up a fourth x, x to the fourth, plus stuff that I don't care about when it comes to end behavior. And by the way, you can actually get this leading term without writing it out. You just have to think 5 times x squared times x squared, whichever works for you. So let's analyze this leading term. We know that the degree is even. That means that we have equal ends. So the ends will do the same thing. And the leading coefficient is positive. That means that the right points up, so the right rises. So what does this mean about the ends? Well, if the right rises and the ends are equal, then the left rises. And as we've already said, the right rises. So both ends of this graph would point up. What about part C? Have you figured that one out yet? Do you know what the ends do? Well, let's unpackage the leading term. Now, as far as this negative x squared goes, it's not really necessary to write negative x times x. You can just leave it as negative x squared. In fact, I don't even need to expand any like I did up here because none of my parentheses had a power. All I have to do is take this leading term of that factor, it's the only term in that factor, the leading term of this factor, and the leading term of that factor. Well, first off, it's negative times positive, so it's going to end up negative. And how many total x's? Well, there's 2 plus a third plus a fourth. So this will start with negative x to the fourth. And by the way, the degree is just the sum of the degrees of the factors. First degree, second degree, 1 plus 2 is 3. Second degree, 2 plus 2 is 4. Second degree, first degree, 2 plus 1 plus 1 is 4. All right, so the degree is even. So an even degree means that we have equal ends. And the leading coefficient is less than 0, which means that the right falls. So what does this mean the end behavior is? Well, if the right falls and the ends are equal, then the left falls. And as we've already said, the right falls. So it's not really that difficult to analyze the end behavior of a polynomial function's graph if that function is already factored for you. You just have to dig out the leading term by multiplying the leading terms of the individual factors together and then analyzing it the same way that we did before.